Our first speaker is Mr. Tom Martin. Tom is the author of numerous publications about the Colorado River, running it and boating through it. Tom has served 2 terms as a board member on the Grand Canyon Historical Society. He has recorded the recollections of over 180 individuals in over 500 recordings and generated over 300 transcripts as part of the Society's oral history program. Working with the Park Service staff and historians across the country, Martin recently completed Volume 1 of a biography of Otis Martin. The title of his talk, The Navajo Bridge, Ralph Hoffman, Jerry Cannon, and 2 bridges named as one. Please welcome Tom Martin.
This presentation is based on a book by Jerry Cannon called The Navajo Bridge. I need to thank a whole bunch of people, which I'll say, thank these people, because I got 20 minutes. I got 100 years, you know the story. This is the Southwest Desert. We are out in the middle of friggin' nowhere. But for thousands and thousands of years, we as a people have been walking through this area all over the place. And it wasn't until really recently that horses and wagons showed up, and that changed our ability to walk in this landscape, because now we were in trouble, because horses and wagons didn't like this place. So by the 1870s, there were a number of ferries trying to get horses and wagons across the landscape. And here at the Colorado River, Lee's Ferry, 1872. Railroads were the way we got around back then, and guess what? There's no railroads in northern Arizona and southern Utah. It's a big blank area on the map. Okay, the first Lee's ferry boats were oar-powered. Imagine you got to row horses and wagons across the river. Good luck with that. The first cable came in 1899, and the loads were getting bigger and heavier, and the automobiles arrived, and everybody wanted to cross at once with 2 cars, and the ferry got bigger. And the first person to really champion a bridge at Marble Canyon was this woman, Charlotte Hall, in 1911. It took a while to actually get the funding together, and Carl Hayden, our new representative to Congress, robbed the Navajo tribe's royalty fund to the tune of $100,000, and the press went wild about it. Governor Hunt said, oh, I'll match that with $180,000, and the money was there. The Navajo, Chee Dodge, the first tribal chairman, went to Washington, D.C. to try to stop the steal, and they failed. So, with money available, this brilliant guy, Ralph Hoffman, designed the first Navajo bridge. The structure that he designed was light and airy, and the bridge was below you. It didn't have big towers and big cables like the Golden Gate Bridge above you, and it had railings you could look through to see what you were doing and where you were going. This is Ralph Hoffman's genius. The roads were pretty good from Flagstaff to Cameron to the South Rim, but from there to the bridge site was a little different. The award to fabricate the steel and erect it was given to Kansas City Structural Steel in Argentine, Kansas. And a senior guy came out, Al Myers, and he's looking around going, how are we going to do this? And he finds Eldridge Moore's a brilliant trucker. And I wish I had a better picture for Eldridge, but I don't. The guy got in today's money about $1 million to transfer the steel out to the job site. He had to hire someone to build a road from Cameron out to the job site. And he did that, got the steel out there. I'm going to go into a little bit about how this bridge is made, but I'm going to show you a film, and the film is going to do it. Thanks to the Al Myers family for this film. Let's see if it works. A little homage to the almighty electron.
Here in northern Arizona, for hundreds of miles surrounding the bridge site at Marble Canyon, the country is rugged and mountainous. Trails lead to many historic places, large petrified forests, balanced rocks, and hogans of the Navajo Indians. Marble Canyon, cutting the country in half, derives its name from the fine-grade marble of its walls, 600 feet apart at the top and reaching down 500 feet to the Colorado River below. Here, a deck arch type of bridge was considered most economical. Many obstacles had to be overcome in delivering materials to this site. Steel was delivered to the railhead at Flagstaff, and special trucks were required to transport through the bridge site 140 miles away. It was thought possible to transport lighter members across the canyon by smaller trucks, and an attempt was made to do so. Here we see how light beams, made as short as possible, were lashed to the side of this small truck, and the trial haul was started over the Mormon Dugway, a narrow one-way mountain road. The trail, as you can see, was very rough and crooked, with steep grades, deep gullies, and no bridges. This long, winding, tortuous road led down to the bank of the Colorado River. Crossing the river at Lee's Ferry, however, proved impractical. A few days after this scene was taken, the ferry was wrecked, and this method of transporting the smaller steel members had to be abandoned. "75 miles of new roads had to be built to accommodate these special trucks. In making the 140-mile haul from Flagstaff to the bridge site, the trucks traveled almost continuously day and night. It required 29 hours to make the round trip. Steel comes to the job ready for construction. Every member is a unit with a definite position in the structure and can be placed without delay. With foundations completed, the work of erecting begins. As we watch the sure-footed workers tackle their job, the compactness of structural steel becomes apparent. Thousands of rivet holes match corresponding holes in adjoining parts with such precision that rivets are inserted without any further preparation. Stresses have been computed exactly, even to the stress in each individual rivet. Steel members are clearly marked for their place on the job, are identified and sorted for the erecting crews. In order to control the fitting of the center hinge pin of the arch, large diamond-shaped jacks or toggles are introduced at each end of the bridge. These jacks have a capacity of 700 tons each and will be operated when the center pin is placed. Stationary engines that will operate these jacks now supply power for the booms on the Traveler. The steel is rolled out on dollies and is swung by the booms out over the canyon. With the lower cords projecting out into space, sections begin to take form. As steel follows steel with clock-like precision, we get a new understanding of the steel worker and the material that he handles. To the lay mind, it seems like putting together a giant puzzle, but it is not a puzzle to the steel fabricator or engineer. Nor is there any puzzle in the steel itself. Every process in making steel, from its refinement to the final passing through the rolls, is supervised and safeguarded to maintain uniform quality. The erection of the steel frame proceeds more rapidly than any other type of fire-resisting construction. Cold weather will not delay it, and the hottest summer temperature will not affect it. Regardless of weather conditions, steel construction proceeds from the Arctic to the equator. Progress in erection is marked by the advance of the Traveler. The Traveler works by setting the farthest filling-in pieces in a panel first. Building nearer itself until the last piece is set, it is then moved forward. Unmindful of the ever-present danger that lurks in a misstep when aloft, the steel worker depends upon his sense of balance as he goes about his job, giving little thought to great height or the river below. He takes it all in his stride. Exposure to the brilliant Arizona sunshine made the task of the steel erector something to write home about. We know of men bundling up for protection against extreme cold, but here's one for Ripley. During summer, these men actually had to don heavy underwear, thick gloves, and stout shoes to protect them from sunburn and the heat of steel. Here we have an example of temperature high enough to scorch the human foot through the leather sole of an ordinary shoe, with the work of erection proceeding uninterrupted and the efficiency of the material unaltered, proving that it is practical to build anywhere, anytime with steel. Riveting crews followed closely in the wake of pinning and bolting, with perfect timing between the red-hot rivet toss and the riveter's bucket. As the steel of the structure projects farther out into the space of upper air, the loads on the steel anchors become greater and greater. With the erection of the first half of the arch completed, the Traveler is dismantled preparatory to its transportation and erection on the opposite side. While this work was going on, a man out on the traveler boom was able to throw a bolt attached to 300 feet of stout cord across to the other side. To this was attached a wire, and to the wire a cable. And by this simple method, transportation for men and materials across the canyon was established. In erecting the first half of the arch, all materials and supplies were transferred from the storage yard to the erectors by dollies. In erecting the second half, all men, materials, and necessities had to be transported by cableway. Greatest of all necessities in this land of golden sunshine is water, and plenty of it, as the size of this drinking water container attests. Keeping the cableway lubricated combines the talents of the steel worker and the circus acrobat. We have seen these steel members transported over rough mountain roads, and now we see them carried over a great natural barrier. They require no freighting or special carriage. Construction being dependent upon the traveler, no time is lost in its reassembly and erection. From across the deep gorge now comes the great shoe, and the work of erecting the second half of the arch gets underway. Here we see the steel anchors and how they are secured in rock tunnels, 125 feet long, with each anchor capable of holding 1,000 tons. The sun shining on one side of the bridge in the morning and the other side in the afternoon subjected not only the men to extreme heat, but the steel as well. Structural steel maintains its strength to a remarkable degree in the presence of atmospheric heat. Investigations have shown that it actually increases in compressive strength with a rise in temperature. Careful calculations are made throughout the entire construction of the bridge. Over 30 triangulation readings were taken in order to determine the exact location of the shoes. Temperature expansion of the anchor steel lowered the location of the center pin 3.5 inches daily, and the effects of the sun's rays would move it up or downstream as much as 3 inches. These changes were carefully taken into account, especially so when preparing to place the center hinge pin. The toggles controlling the center hinge of the arch are now operated while the pin is put in place. One must be impressed by the comparatively small number of men who, with simple machinery, have handled and erected the many steel members that form the bridge. The Navajo Indians paid for these high, closely latticed railings we see being erected as a protection for their herds of sheep and goats in crossing. The length of the arch span is 608 feet. The total length of the bridge with approaches is 832 feet, with the bridge floor 500 feet above the water. Thus, in spanning the Colorado River at Marble Canyon, steel has made another contribution to the advancement of civilization.
Please raise your hand if you've seen this film before. One. Good. Okay. The film didn't mention a steel worker that fell from the center down to the river, but these steel workers were all Kansas City structural steel guys, and I attribute to them. The bridge was in place, and the press called it a wagon bridge, out in the middle of nowhere. Well, the Park Service needed that bridge, and they got it. And things changed. The bridge did its job through the 30s, through the 40s, through the 50s, but vehicles got heavier, and transportation got faster, and some very fascinating things happened. Grand Canyon National Park snuck in under the bridge in January of 1975. How cool is that? Wow, there were a bunch of environmental laws and historical preservation laws that snuck in the 70s as well. Huh, okay, and we had this problem. Oh, whoa, look at that. Stop, get out. And we had this problem. Hey, buddy, wait, you back off for a second, let me through. And the glass from the rearview mirrors littered the bridge. The Department of Transportation in Arizona knew they had a problem. They had a mess of a bridge. They needed to do something, and compliance was a huge issue. Introduced Jerry Cannon. This is Cannon Associates. Jerry's the guy in the brown suit in the middle there. A brilliant man who knew how to bring people together. He was awarded the contract to get this thing rolling. The first thing he did was meet with the Bodaway Gap local chapter grazing committee. Then he gave a presentation at the chapter house. Then he went to Window Rock, and he started bringing together everyone who had anything to do with this project. It took 8 years to get the compliance all together. Absolutely fascinating he was able to do it. Cannon was a pretty brilliant guy, just like that Hoffman fellow. Cannon said, I'm going to build another bridge next to this one. It's going to be wider, it's going to be stronger, and we're going to solve a whole bunch of problems. But Cannon had some interesting things to deal with. I'll just mention one. In the 20s, when they built the foundations, they knocked all that rock down into the river, and that's why there's a little riffle there. This wasn't the 20s anymore, and what they had to do, they let some rock go into the river, the rest of it had to come out. 16,000 cubic yards of rock was removed, didn't go into the river, like we're going to see right here.
Some areas on the cliff face were determined entirely impractical to contain or to stabilize. The upcoming blast sequence will remove an overhang of 16 feet at the top edge of the future skewback foundation. Permission from the Park Service was obtained prior to the design of the shop. Their direction was to put as much pulverized rock into the river as possible. As funny as that may sound, the idea was not to create a talus slope, nor to create a rapid as might happen with a concentrated rock fall into the river. By most accounts, the blast was a complete success. Beautiful. Absolutely beautiful. Perfect.
There was a couple of things I want to mention. I had a chance to visit with the guy running the crane. Now, crane operators on job sites are on the ground, and everything goes way up overhead. The guy was afraid of heights. How he managed this is an amazing story for perseverance right there. This is the Navajo Bridge. I want to mention that this is the topping out ceremony. You rarely see this. There's a Navajo Nation flag there with the American flag on the last piece of steel being placed by the ironworkers, the majority of which who were Navajo. How cool is that? 2 men, 2 bridges, 1 name. Thank you very much. I hope you enjoy the symposium.